Hi everybody, I'm Iain Cunningham from Vector GB. Welcome to this episode of Engineering the Jigsaw, where we're going to take a look at the AUTOSAR adaptive platform. As we've mentioned before, AUTOSAR is a trademark, both the word and the logo that you see here. So without any further ado, let's get into episode foundation level number 9, where we're going to get into the AUTOSAR adaptive platform. We're really going to build on the content that we went into in episode F6, what is AUTOSAR, and therefore that's really a prerequisite for this episode today. And of course, F8, where we talked about HCPs or HPCs, depending which way around we put those letters, that's also a prerequisite, which really leads us in nicely to this episode we have today. So, up to now, we've talked about software, but we haven't really talked about the need for predictable behaviour in vehicles, which is something that we all rely on every time we are in a vehicle or nearby a vehicle on the road or walking as a pedestrian. And what we have is inside the ECUs, the functions in the software of the ECU, or tasks as they're known in embedded software engineering terminology, these run periodically to a defined schedule. So this means that every so often the task will run, and this repeats this schedule. And while the task runs, it checks inputs that are relevant to it, and it operates outputs accordingly to what those inputs are doing. And the tasks have to execute within a limited amount of time. That means they have to complete before a deadline expires. Now, the reason for this is, of course, if we think about ABS, it's immediately obvious. If a wheel starts to skid, failure of the software in the ABS ECU to meet its deadlines could be catastrophic for the vehicle and its occupants, which could be us. So deadlines are important. And the task schedules and the deadlines for tasks are typically defined in terms of milliseconds. And nowadays, even with motor control, we're starting to see task scheduling being defined in terms of microseconds, so in terms of 1/1,000,000th of a second. And a single task that overruns or misses its deadline will have a knock-on effect that means other tasks will fail to meet their deadlines. So every task has to complete before its deadline, or none of them can potentially meet their deadlines. And this need to meet strict deadlines via predictable execution is called hard real-time. So you may have heard about people talk about hard real-time behavior or real-time behavior. So hard real-time behavior means no task can miss its deadline. And hard real-time behavior is something that may, really important, not always, may be achieved with the AUTOSAR Classic platform. There's a lot of stuff you have to do, even with the AUTOSAR Classic platform, in terms of scheduling and making sure your tasks are coded efficiently to make sure that you can meet your deadlines. It's not a given. The AUTOSAR Classic platform isn't a silver bullet. Predictability is one thing, but future vehicles, we need other things. ACEs. So what are ACEs? Well, actually, this is an abbreviation, and the A stands for automation or autonomy. Sometimes you'll see this referred to. So this is something we talked about in episode F8. Also, connectivity is a topic, and this is the C. For E, we have electrification. Of course, a major topic to try and reduce pollution and minimize our impact on global climate. And S is sharing, and not just sharing of vehicles, which maybe lots of people think about, but sharing of data. So the ability we talked about way back in episode F1, the 50,000 piece jigsaw puzzle, of vehicles to communicate maybe with infrastructure to a computer, which will then aggregate the information from lots of vehicles, work out where traffic jams are, and then help vehicles find their way around those traffic jams. That kind of sharing as well. And of course, we want to be able to perform over-the-air updates. Unfortunately, the over-the-air updates is not part of ACEs, but it kind of comes with it. It's part of the connectivity, maybe part of the sharing, and of course, we want to be able to improve our functions. So over-the-air updates, really, really critical when we start to get into the ACES functions. And if we go back and just quickly think about what we talked about in episode F8, what is an HCP? Well, the HCP is a high-performance computing platform, and we put it into our vehicles to provide those ACES functions. It is software then that's running in a POSIX environment, such as Linux. We talked about Linux being a POSIX environment, and it operates alongside the ECUs that run the AUTOSAR Classic platform. So the AUTOSAR Classic platform is there giving us our hard real-time behavior that we need to know that when things are operating, they're operating within the time period that makes everything acceptable for us. And it does, the ACES functions then are like a layer on top of that gives us other capability, because they use dynamic service-orientated communication. We talked about the difference between a desert road and a busy city street intersection, or a busy highway during rush hour. So it's really dynamic processing and data throughput that we have with these ACES functions. So we have a POSIX platform. And the AUTOSAR adaptive platform actually assumes that a certain subset of POSIX features is provided by an operating system. This subset is referred to as PSE51. So you can find the POSIX specifications and find this profile. It's called a profile within the specifications. And AUTOSAR adaptive really relies on this operating system being present, while the classic platform, if you go back to F6 and pause the video, you'll see that actually that contains an operating system. It includes an operating system. There's a little box in there which is OS. So this is quite different. And the adaptive platform then defines application programming interfaces, which is a way for adaptive applications to interact with functional clusters within the HPC or HCP, together with adaptive platform services. And what we say is the adaptive applications actually access the AUTOSAR runtime for adaptive applications, or ARA for short. So if we think about the classic platform, we have the RTE, where we have our application software above there. We can maybe think that the ARA and the RTE are very roughly equivalent. But hey, what is functional platform what? So let's just step back a second. Well, a functional cluster. This is a group of related capabilities, such as accessing network data, whether receiving it or sending it, and storing or retrieving data locally, or more technically persistence, or performing internal logging if a problem occurs. So it's a group of related stuff. So we have a communication functional cluster that allows us to access network data. We have a persistence functional cluster. We have a log and trace functional cluster, and there are others. And of course, an application may not actually need to use all of these. The platform services, though, provide a standardized way to access capabilities that are always available within the AUTOSAR adaptive platform, such as understanding the present state of the platform. So are we starting up? Are we shutting down? And also network management. So the ability to understand if a network is active or if a network's able to be shut down, maybe to save power. These are the functional cluster and the platform services. So we have these together making up the ARA. And really, again, a big difference to the AUTOSAR Classic platform. The AUTOSAR Classic platform only specifies what you can see here. So this very small number of things is what's specified, and it really specifies the APIs. The behavior is left, and communication between the functional clusters and services is really left up to the people developing the software. Whereas the classic platform we talked about before has over 100 modules defined and really well-defined interactions and behavior between them all. So it's all really tied down. The adaptive platform's a bit different. The adaptive platform also allows adaptive applications to be developed using an object-orientated language, which is known as C++. This is different to Classic again. Classic uses a classic signal-based, mostly signal-based, because it can also do service-based language, which is C. And along with this, the adaptive platform allows the use of libraries that provide advanced functions, such as object recognition, that are needed by ACE's functions. So these libraries typically, if we need to recognize an object and characterize properties of that object, obviously an object-orientated language fits to that really well. And the adaptive platform then also, through the dependency to POSIX, allows adaptive applications to be updated and added or removed during runtime, just like you can do on a smartphone. You can add an app to your smartphone or your tablet and you can remove it, or you can update it, and you don't have to restart your phone when you do this. So the reason for this is that adaptive applications run as individual POSIX processes. So each application can be individually shut down and restarted if we need to, or individually updated and removed, or whatever we want to do with them. As a summary, the adaptive platform provides access to the computing power needed by future vehicles, those ACEs functions, the autonomy, connectivity, electrification, and sharing functions. The classic platform, of course, is going to remain in vehicles for the hard real-time behaviour that we rely on beyond those ACEs functions for many years to come. And the adaptive platform relies on a POSIX-compliant operating system being present, unlike the AUTOSAR Classic platform, which contains an operating system itself. And the adaptive applications that we have then run as individual POSIX processes, and this allows them to be dynamically loaded or unloaded, or dynamically installed and uninstalled without needing a restart of the platform. If we contrast this to episode F7, we talked about how in a traditional kind of ECU bootloader scenario, we have to stop the application completely running, all the software stops running, the bootloader takes over, and then we can update the ECU. So this is really different between the classic platform and the adaptive platform. The adaptive platform also is based on service-orientated communication and object-orientated programming with C++ to match those ACEs functions. And it provides an ARA, the AUTOSAR runtime for adaptive applications, that is comprised of or composed of APIs that give access to the functional clusters as well as the platform services that the adaptive platform provides. Lots of information in a short amount of time in this episode. So this is a new and evolving topic, and in our next episode, How is the Jigsaw Evolving? We're going to look at how vehicle EE systems are changing to include the AUTOSAR adaptive platform. If you go to the Vector website, of course, you'll be able to find details of Vector's data-centric engineering platform for the design and analysis of software-defined vehicles, which are data-centric systems that are based on the AUTOSAR adaptive and classic platforms. This is called Prevision. We have embedded software for the AUTOSAR classic and adaptive platform specifications, so classic micros and adaptive micros respectively. We also have tools for testing adaptive applications and the HCPs that they run on within data-centric EE systems. We call these tools Canoe and Canoe for software. We also have, of course, detailed technical training on the adaptive platform and many free webinars, technical articles on all these topics and also related topics. And of course, you can go to the AUTOSAR website and obtain the full set of specifications for the AUTOSAR adaptive platform as well. So thank you very much for joining us for this episode. I hope you've enjoyed it. As always, if you have any questions, please leave a comment where you've found this video or the link to the video, or drop us an email at engineering.jigsaw@vector.com. And please let us know if there are any topics that you'd like us to cover in a future episode. I'm Iain Cunningham from Vector GB. Thank you for joining us again. Bye.